Blockchain technology is revolutionizing the world as we know it. From cryptocurrencies to decentralized applications, blockchain is laying the foundation for a more secure, transparent, and efficient digital world. While proof of stake and proof of work have stolen the spotlight in recent years, there's a whole new wave of exciting consensus mechanisms that are changing the game. In this video, we're diving into some of the latest and most innovative proof of mechanisms that could shape the future of blockchain and cryptocurrencies. We'll break down everything from proof of view to proof of space and more. Let's explore how each one contributes to the blockchain ecosystem and why they matter for the future of digital assets. Before we get into the specifics, let's first talk about what a consensus mechanism actually is. In simple terms, it's the protocol used by a blockchain network to achieve agreement on the state of its distributed ledger. Think of it like the rules of the game that help every participant agree on which transactions are valid and should be added to the blockchain. Without a consensus mechanism, the system would collapse because there would be no way to verify which transactions are legitimate and how blocks are added to the chain. A consensus mechanism ensures that everyone in the network plays by the same rules, helping prevent fraud and maintaining network integrity. It's the backbone of any blockchain, keeping the network decentralized, trustworthy, and secure. The more reliable the consensus mechanism, the safer and more efficient the blockchain is. When we talk about blockchain, we can't leave out proof of work, the original consensus mechanism that powers Bitcoin. Proof of work is essentially a race against time, where miners use their computational power to solve complex mathematical puzzles known as hashes. The first miner to crack the puzzle gets the right to add a new block to the blockchain and is rewarded with newly minted cryptocurrency. However, proof of work isn't without its flaws. While it's been a game changer for decentralization and security, it comes at a heavy price. The process of solving these puzzles is extremely energy intensive and requires huge amounts of computational power. Every time a miner solves a puzzle, it uses an immense amount of electricity to keep the network running and secure. For example, Bitcoin mining alone consumes more energy than some countries combined. This massive energy consumption has sparked significant environmental concerns, especially as blockchain adoption continues to grow. The carbon footprint associated with proof of work mining is causing many to rethink the sustainability of such networks. So, how can we make blockchain more sustainable while still ensuring it remains secure and decentralized? That's where the proof of stake mechanism enters the picture. The proof of work consensus mechanism has been around since the early days of blockchain and is famously known for securing the Bitcoin network. It relies on miners solving complex mathematical puzzles to validate transactions and add them to the blockchain. While proof of work has faced criticisms for its high energy consumption, it is still widely used in many successful blockchain projects. Here are some of the most notable cryptocurrencies that operate on proof of work. Bitcoin, launched in 2009, is the first ever cryptocurrency and the most well-known and widely used PoW-based blockchain. Miners use powerful computers to solve cryptographic puzzles, and the first miner to solve the puzzle gets rewarded with newly minted Bitcoin. Bitcoin's PoW mechanism is highly energy intensive, contributing to its environmental concerns, but also ensuring its decentralized nature. Litecoin, launched in 2011, is considered the silver to Bitcoin's gold and is also powered by PoW. It was created to address some of Bitcoin's limitations, such as slower transaction speeds and higher fees. Litecoin uses the script algorithm instead of Bitcoin's SHA-256, which makes it slightly more memory intensive and faster for mining. While still energy intensive, Litecoin's script algorithm is less demanding than Bitcoin's, making it somewhat more efficient in terms of mining. Bitcoin Cash, launched in 2017, was created as a result of a hard fork from Bitcoin, aiming to solve Bitcoin's scalability issues. The network increased the block size limit, allowing more transactions to be processed per block. Like Bitcoin, Bitcoin Cash also relies on PoW mining to validate transactions and secure the network. As Bitcoin Cash uses PoW like Bitcoin, it suffers from similar energy consumption issues. However, it offers faster transaction speeds due to its larger block sizes. Ethereum, launched in 2015, initially used PoW, just like Bitcoin, to secure its network. However, Ethereum has been transitioning to proof of stake with Ethereum 2.0 to address scalability and energy efficiency issues. Despite this change, ETH's POW mechanism was vital in the early stages of Ethereum's growth as the second largest cryptocurrency in the world. Ethereum's POW was energy intensive, with miners contributing large amounts of power to secure the network. The network's move to PoS is aimed at reducing energy consumption and increasing scalability. Monero, launched in 2014, is a privacy-focused cryptocurrency that prioritizes anonymous transactions. It uses POW mining to secure its network and validate transactions, making it resistant to surveillance. Monero employs the RandomX algorithm, which is designed to be CPU-friendly and resistant to mining with specialized hardware. Monero's RandomX algorithm ensures that CPU mining is the most efficient form of mining, making it less energy-intensive than ASIC-based mining used in Bitcoin and other POW networks. Zcash, launched in 2016, is a privacy-centric cryptocurrency built on the zk-SNARKs protocol, which enables users to make private, shielded transactions. Zcash uses the Equihash POW algorithm to validate transactions and secure the network. Zcash's POW mechanism, like Bitcoin, requires significant computational resources, but its privacy features set it apart as a popular alternative to Bitcoin for those who value anonymity. Dogecoin, launched in 2013, was initially created as a meme cryptocurrency, but has grown to become a popular digital asset, largely due to its low transaction fees and the support of high-profile figures. Dogecoin uses a script-based POW system similar to Litecoin, making it easier to mine. Dogecoin's POW algorithm is less power-intensive compared to Bitcoin's SHA-256, but still requires significant energy consumption for miners to validate transactions and create new blocks. Dash, launched in 2014, focuses on fast and inexpensive transactions and offers a unique feature called Instant Send, allowing transactions to be processed in seconds. It uses POW mining to secure its network and ensure the integrity of the blockchain. Dash also employs a hybrid consensus mechanism with masternodes, allowing for governance and quick decisions. Dash's POW mechanism is energy-consuming like Bitcoin's, but the network has taken steps to optimize efficiency with masternodes and a more centralized decision-making process. Ravencoin, launched in 2018, is a blockchain built for creating and transferring digital assets. It uses the PoS algorithm, which is designed to be resistant to mining with ASICs and can be mined efficiently using GPUs. Ravencoin offers an easy-to-use platform for tokenizing assets, making it popular among developers and creators. Ravencoin's POW model is energy-intensive, but the use of GPUs rather than ASICs allows for decentralized mining and a more accessible entry for individual miners. Bitcoin SV, launched in 2018, is a hard fork from Bitcoin Cash that focuses on scaling the Bitcoin network to support large transaction volumes. It uses the SHA-256 POW algorithm, like Bitcoin, to validate transactions and add blocks to the blockchain. Bitcoin SV shares similar energy consumption characteristics to Bitcoin, making it a high-energy blockchain solution with the goal of supporting enterprise-level applications. While proof of work continues to be an essential part of many successful blockchain projects, its energy demands have sparked the rise of alternative consensus mechanisms, such as proof of stake and proof of space, that aim to make blockchain more sustainable. However, proof of work is still critical to the decentralization and security of many projects. Whether it's Bitcoin, Litecoin, or Dogecoin, the POW mechanism continues to play a pivotal role in the growth and development of cryptocurrencies and decentralized applications. As blockchain evolves, we can expect more projects to explore and implement hybrid models or alternative consensus mechanisms. The blockchain space is constantly changing, and POW still remains a foundational technology in the world of cryptocurrencies. Enter proof of stake, the energy-efficient alternative to proof of work. Unlike POW, which relies on miners solving complex puzzles to validate transactions, PoS uses validators who stake their cryptocurrency to participate in the network. The more cryptocurrency you lock up in the network, the higher your chances of being chosen to verify transactions and add new blocks to the blockchain. How does PoS work? Validators lock up a certain amount of their own cryptocurrency as collateral, which they risk losing if they act maliciously, or fail to validate properly. The idea is that those with more at stake have more incentive to act honestly. Validators are selected to create new blocks based on factors such as the amount of cryptocurrency they've staked, how long they've been staking, and sometimes even randomization. Validators check and confirm transactions, adding them to the blockchain without the need for energy-consuming mathematical computations. This makes the entire process far less resource-intensive. The PoS consensus mechanism dramatically reduces the environmental impact compared to POW by eliminating the need for high-powered mining rigs, thus significantly lowering electricity consumption. It's not just a greener approach, PoS also increases scalability, enabling faster transaction times and a more sustainable network. Why the shift from POW to PoS? Projects like Ethereum have transitioned from POW to PoS with Ethereum 2.0 to improve scalability and transaction speeds while addressing growing concerns about the environmental cost of POW. The transition aims to make the system more sustainable in the long run and bring greater efficiency to the blockchain network. As Ethereum 2.0 embraces PoS, it brings several benefits: faster transaction times, lower fees, and more security. The staking model creates an incentive for validators to follow the rules, improving network security. Crypto projects that use proof of stake include Ethereum 2.0, which started the transition in 2020 and aims to address scalability and energy concerns by moving from POW to PoS. Cardano, launched in 2017, has been built from the ground up to use PoS to verify transactions, focusing on creating a sustainable and scalable platform for smart contracts. Polkadot, launched in 2020, uses a unique nominated proof-of-stake model that encourages collaboration between parachains. Tezos, launched in 2018, offers users the ability to participate in the validation process by either staking their tokens or delegating their stake to a validator. Solana, launched in 2020, uses proof of history alongside PoS to offer a highly scalable and fast blockchain network. Cosmos, launched in 2019, aims to enable interoperability between various blockchains using a Byzantine fault-tolerant PoS protocol. Algorand, launched in 2019, aims to provide a scalable, secure, and decentralized blockchain with pure PoS. The benefits of PoS include energy efficiency, scalability, security, and low transaction fees. In conclusion, proof of stake is gaining momentum as a more sustainable, energy efficient, and scalable solution for blockchain consensus. As the industry moves toward greener alternatives, PoS projects like Ethereum 2.0, Cardano, and Polkadot are setting the stage for a more eco-friendly future in blockchain technology. Next up is proof of authority, a consensus mechanism where a trusted set of validators are pre-approved to add blocks to the blockchain. Unlike POW or PoS, PoA doesn't rely on computing power or staked tokens to validate transactions. Instead, it depends on reputable authorities who have been granted permission to validate and add blocks. The network is controlled by a set of trusted validators that have been vetted by the network operator or community. These validators are typically well-known entities with a reputation to protect. PoA allows for faster transaction processing and quick block confirmations since the number of validators is limited and trusted, so there's no need for complex calculations or staking. PoA is an ideal consensus mechanism for private or permissioned blockchains where speed, efficiency, and high performance are paramount. PoA systems are able to handle large numbers of transactions quickly without needing massive computational resources, making them more scalable and cost-effective compared to POW or PoS. It's a win for enterprise-level applications or systems that prioritize performance and efficiency. While PoA offers fast and efficient transactions, it comes with a centralization trade-off. With only a small number of validators in charge, the system is much less decentralized than POW or PoS. PoA isn't ideal for public blockchains that prioritize decentralization because fewer validators mean less distribution of power. In PoA systems, the decision-making process is concentrated in the hands of a few trusted parties. Since the validators are often known, there may be concerns about collusion or centralized control, reducing the level of trust in the system. Only a select group of pre-approved entities can participate in transaction validation, so the network is more restrictive in terms of who can join and participate. For public blockchains, decentralization is often considered essential, which is why PoA is less commonly used in the open blockchain space and more common in private or enterprise blockchains. While proof of authority isn't as widely used in public blockchains, it has found a home in private and enterprise-grade blockchains that value speed and efficiency. Here are some of the prominent projects using PoA. VeChain, launched in 2015, utilizes PoA to ensure scalability and high performance while focusing on business applications like supply chain management. Trusted, pre-approved authorities validate transactions on the VeChain blockchain, making it a perfect fit for businesses and logistics companies. Ethereum Classic, launched in 2016, primarily operates on proof of work, but some implementations of PoA have been explored within its ecosystem, particularly useful for sidechains and enterprise-focused projects. PoA Network, launched in 2017, is a public blockchain built entirely on proof of authority, providing a highly scalable platform for decentralized applications with fast finality and low-cost transactions. Xdomain, launched in 2020, is a multi-chain platform designed for cross-chain transactions, offering a fast, secure, and efficient network for enterprises. OneChain, launched in 2017, focuses on interoperability between different blockchains, providing a scalable, low-latency network for cross-chain transactions. The benefits of PoA include speed and efficiency, allowing for faster transaction times and low latency, making it suitable for high-performance use cases. Without the need for extensive mining or staking, PoA blockchains typically have lower transaction fees. By relying on trusted validators with a known reputation, PoA can offer greater network reliability. It works best in permissioned environments, such as enterprise solutions, private applications, or consortium blockchains where trust is paramount. However, the key drawback of PoA is its centralized nature, as decision-making is restricted to a small group of validators. This goes against the decentralized ethos that most public blockchains follow. Only a select group of approved validators can participate, reducing inclusivity and decentralization. Since PoA relies on known entities, if these validators collude or act maliciously, it can compromise the integrity of the network. In conclusion, proof of authority is a fast and efficient consensus mechanism that is perfect for private blockchains and enterprise use cases, but it's not ideal for systems that prioritize decentralization. While it offers scalability, low-cost transactions, and high performance, it does so at the cost of centralization, making it more suitable for businesses and private networks rather than public applications. Let's switch gears and talk about proof of space, also known as proof of capacity. In PoS space, miners don't rely on computational power to secure the network. Instead, they use hard drive space to participate in the mining process. The more storage space you have, the higher your chances of being selected to validate transactions and add new blocks to the blockchain. How does proof of space work? Miners, often referred to as farmers, use their available hard drive space to plot cryptographic data. This data is generated through an algorithm that fills the hard drive with plots. Once the hard drive is filled with these cryptographic plots, the farmer can be selected to validate transactions. If their storage is selected, they validate the transaction and earn rewards. Since PoS space doesn't require intense computational work, it is much more energy efficient and eco-friendly. This makes it a more sustainable alternative to traditional proof-of-work mining, which consumes significant electricity. The effectiveness of PoS space is tied to the amount of storage capacity you have, meaning larger hard drives increase your chances of earning rewards. But, compared to POW, PoS space consumes much less energy and reduces the environmental footprint of mining. Now, let's look at some crypto projects using proof of space. Chia, launched in 2021, is the most well-known project using proof of space. Miners plot their hard drives and store cryptographic data to farm Chia coins. Instead of competing based on raw computational power, Chia farmers earn rewards based on their available storage space. Chia works on a farmer network where participants store data on their hard drives and receive rewards for successfully validating blocks and transactions. Chia's PoS-based consensus mechanism aims to create a more energy-efficient blockchain alternative compared to traditional mining systems like Bitcoin's POW. Miners, known as farmers, plot and store data on their hard drives, offering a greener solution for blockchain validation. Another project is Spacemint, also launched in 2021, which focuses on creating a decentralized and eco-friendly cryptocurrency. The protocol's mining process uses hard drive space to generate rewards for users who contribute storage capacity. Just like Chia, Spacemint farmers are rewarded for providing unused disk space for the network's operation. Spacemint promotes itself as an energy-efficient alternative to traditional mining by leveraging unused hard drive space. Filecoin, launched in 2017, is a decentralized storage network that leverages a modified version of proof of space, called proof of spacetime. Instead of just proving space, miners must also prove that the data stored has been kept over a certain period, adding an extra layer of verification. Filecoin miners rent out unused storage space to store files in a decentralized manner. Users are incentivized to provide storage capacity in exchange for Filecoin rewards. By utilizing unused hard drive space from miners, Filecoin promotes an eco-friendly, energy-efficient system for decentralized data storage. Miners provide storage space and are required to demonstrate that the data is being stored for a period of time to validate transactions. Burstcoin, launched in 2014, is one of the earlier projects that used proof of space for mining. Instead of relying on computational power or electricity-hungry mining rigs, Burstcoin miners use available hard drive space to mine coins and validate transactions. Burstcoin uses hard drives to mine coins by storing cryptographic data and performing space-efficient mining. It is often seen as a more eco-friendly alternative to traditional mining. Unlike Bitcoin, Burstcoin miners don't need to consume tons of energy, making it an environmentally friendly cryptocurrency. Lastly, Storj, launched in 2018, is a decentralized cloud storage platform that uses proof of space to incentivize participants to provide storage for decentralized data storage. Users can earn Storj tokens by offering their unused hard drive space to the network. Like other PoS-based projects, Storj farmers earn rewards for sharing their storage capacity with the network. Storj utilizes unused storage capacity to allow individuals to contribute to the network, making it an energy-efficient alternative to centralized cloud storage services. The benefits of proof of space include energy efficiency, sustainability, lower costs, and scalability. PoS space is much more energy efficient than traditional proof-of-work mining, as it doesn't require massive computational resources to validate transactions. Since PoS space only uses storage space, it significantly reduces the environmental impact of mining compared to POW systems. Instead of spending a lot on hardware or electricity, miners can use existing hard drive space to participate in the network. The ability to store large amounts of data makes PoS space scalable for decentralized applications and storage solutions. However, there are drawbacks to proof of space. Success in PoS-based mining depends on the amount of storage capacity a miner can provide. Those with larger hard drives have a better chance of earning rewards. Frequent writing and reading to hard drives can cause wear over time, leading to potential issues for miners and increased maintenance costs. The process of plotting and setting up a hard drive for PoS-based mining can be time-consuming and might require more technical knowledge. In conclusion, proof of space offers a greener and more energy-efficient alternative to traditional proof-of-work systems by utilizing unused hard drive space for mining. Projects like Chia, Filecoin, and Burstcoin show that PoS space is not only good for the environment, but also can offer scalable solutions for decentralized data storage and mining. Proof of view, POV. No more fake engagement. Now, let's talk about something super exciting. Proof of view, POV. Imagine a world where content platforms ensure that views and interactions are real and not inflated by bots. POV validates that digital content, like videos, posts, and even advertisements, has been actually viewed or engaged with by real users. This breakthrough is perfect for creators who want to ensure that their engagement is authentic and transparent, With POV, platforms can reward content creators based on real user interactions, creating a fairer system for everyone. Say goodbye to fake likes and view counts. How does proof of view work? Validation process. In a POV system, platforms track genuine interactions by analyzing user behavior and ensuring that content is truly being viewed and engaged with. This ensures that the views and likes a creator receives are real and not generated by bots or fake accounts. User engagement. When users watch a video, leave a comment, or interact in some other way, their engagement is recorded and verified. POV ensures that the number of views or likes reflects actual user behavior, eliminating fraudulent activity. Transparency. Content creators, advertisers, and even platforms benefit from a transparent engagement system where rewards are based on authentic interactions, promoting fairness and trustworthiness. Crypto projects. Using proof of view, POV. Several crypto projects are now focusing on leveraging proof of view, POV, to tackle fake engagement on digital platforms and reward creators fairly. These projects are blending blockchain technology with user-generated content to ensure that content interactions are genuine and trustworthy. Theta Network, Theta, was launched in 2018 and uses a consensus mechanism of proof of view, POV, plus proof of stake, PoS. Theta Network is a decentralized video streaming platform where viewers can earn rewards for watching content. Through POV, Theta ensures that viewers actually watch content and interact in real time. This system eliminates fake views and promotes genuine engagement between content creators and their audience. Theta uses a hybrid PoS and POV model where viewers can share their bandwidth and earn Theta tokens, Theta, in return. The POV mechanism ensures that rewards are based on real engagement with the content, improving the platform's transparency. The main benefit is that Theta not only offers a more decentralized video streaming platform, but it also guarantees that creators are rewarded based on genuine views and interactions, creating a fairer ecosystem for content creators. Audio, was launched in 2020 and uses a consensus mechanism of proof of stake, PoS plus proof of view, POV. Audius is a decentralized music streaming platform that rewards artists based on real engagement. Through POV, Audius ensures that interactions with music content are from real users, not bots. Similar to Theta, Audius tracks and validates genuine plays, shares, and likes on the platform using POV and POS. Artists earn Audius tokens, audio, based on actual user engagement, promoting a more transparent and fair system for musicians. The main benefit is that for artists, Audius creates a fair ecosystem where they are rewarded for real engagement, eliminating inflated numbers and fake streaming activities. Veracity, VRA, was launched in 2018 and uses a consensus mechanism of proof of view, POV, plus proof of stake, POS. Veracity is another blockchain-based video platform that integrates POV to validate genuine views and interactions. This project aims to combat fraud in the digital advertising space by rewarding content creators based on real views and engagement. Veracity uses POV to ensure that advertisers only pay for real engagement with content, avoiding fraudulent activities like fake views or bots. Content creators earn VRA tokens for their verified views. The main benefit is that Veracity helps to improve the transparency of the video ad industry, ensuring that creators are rewarded for authentic views, while advertisers only pay for real engagement. The benefits of proof of view, POV, authenticity. The POV system ensures that only real users interact with content, promoting authentic engagement for creators and advertisers. Transparency. POV helps create a more transparent ecosystem where content creators, influencers, and advertisers can trust that the views and interactions they receive are genuine. Fair rewards. With POV, content creators are rewarded based on real user interactions, ensuring that the rewards they earn reflect their actual audience engagement. Improved ecosystem. By eliminating fake views and bot activity, POV creates a fairer system for all players in the content creation and advertising space. Challenges of proof of view, POV. Implementation. Complexity. Tracking and validating real user engagement can be complex and might require more advanced technologies to ensure accuracy. Privacy concerns. While POV improves transparency, user privacy could be compromised if engagement data is misused. Scalability. As POV grows in popularity, the technology may need to scale to handle millions or even billions of interactions without slowing down the system. In conclusion, Proof of View, POV, is transforming the content creation and advertising industry by ensuring that engagement is authentic and fair. Projects like Theta, Audius, and Veracity are leading the way in creating a decentralized and transparent system where content creators are rewarded based on real user interactions. Proof of elapsed time, PoET. Another interesting mechanism is proof of elapsed time, PoET, where participants randomly wait for a predetermined period before being chosen to add a block to the chain. The longer you wait, the higher your chance of being selected to validate transactions. The key benefit of PoET is its energy efficiency. Unlike proof of work, POW, PoET doesn't require intense processing power to secure the network, making it an ideal choice for low-energy blockchain systems. This consensus mechanism is being used in Hyperledger Sawtooth, an open-source blockchain platform designed for enterprises. It's a great choice for enterprise blockchain networks that need high scalability and low energy consumption. PoET also ensures fairness in choosing block validators, making it an attractive option for businesses that need a secure and energy-efficient system. How proof of elapsed time, PoET, works. In PoET, validators don't compete for computational resources like in POW or stake tokens like in PoS. Instead, they simply wait for a randomly assigned amount of time. The participant who waits the longest is chosen to validate the next block. The random waiting times are secured through trusted execution environments, TEEs, which ensure fairness and randomness in the selection process. Energy efficiency. Since PoET doesn't require heavy computations or the staking of large amounts of tokens, it's a low-energy alternative, making it especially attractive for enterprise applications. Cryptos and projects. Using proof of elapsed time, PoET. Hyperledger Sawtooth was launched in 2016 and uses proof of elapsed time, PoET. Hyperledger Sawtooth is an open-source blockchain framework designed for building and deploying enterprise-grade blockchains. It incorporates PoET as a consensus mechanism to provide secure, scalable, and low-energy blockchain solutions for businesses. In Sawtooth, validators are selected based on a random waiting period, reducing the need for power-intensive computations. This makes it an ideal choice for use cases like supply chain management, financial services, and other enterprise-level solutions. The main benefit is that Hyperledger Sawtooth enables companies to create customized blockchain solutions with low energy consumption, high security, and scalability. Proof of Burn, POB. Now, let's talk about Proof of Burn, POB, a unique consensus mechanism where participants burn a portion of their cryptocurrency to prove their commitment to the network. Proof of Burn works by having users send coins or tokens to an address that cannot be accessed, effectively removing them from circulation. This action decreases the total supply of the cryptocurrency, which can increase the value of the remaining tokens. By burning coins, participants show their dedication to the network, creating an incentive for long-term holding and investment. How Proof of Burn, POB, works. In POB, participants send their tokens to an address where they cannot be recovered or used. This decreases the total supply of the cryptocurrency, increasing scarcity and potentially increasing the value of the remaining tokens. By burning tokens, users signal their commitment to the network, often earning rewards in the form of additional tokens. POB also helps secure the network by ensuring that only those willing to sacrifice their tokens for the long term are able to validate transactions and add blocks to the chain. Burning tokens leads to deflationary economics, making the cryptocurrency more valuable over time. As fewer tokens are in circulation, the remaining supply becomes more scarce, potentially increasing demand and value. Crypto projects using Proof of Burn, POB, Slimcoin, SLM, was launched in 2014 and uses proof of burn, POB. Slimcoin is one of the earliest projects to use the POB mechanism. It encourages users to burn a portion of their coins to help secure the network and earn rewards. In Slimcoin, users burn their coins, and the network rewards them with the Slimcoin token. Burning coins contributes to network security and ensures that the supply of coins remains limited, which in turn increases the scarcity of the token. The main benefit is that Slimcoin integrates POB to encourage long-term investment in the network, creating a deflationary model where the total supply decreases over time. Counterparty, XCP, was launched in 2014 and uses proof of burn, POB. Counterparty is a platform that allows the creation of custom tokens and assets on top of Bitcoin's blockchain. The platform uses POB as a consensus mechanism to secure its peer-to-peer network and incentivize token creation. In Counterparty, participants burn Bitcoin, BTC, in exchange for XCP tokens, which can then be used to create new assets or participate in the platform's decentralized exchange. The burning of BTC effectively decreases its total supply, creating deflationary pressure that can increase the value of the tokens. The main benefit is that Counterparty combines POB with Bitcoin's blockchain to enable decentralized token creation and trading, while incentivizing long-term commitment from its users. Factom, FCT, was launched in 2015 and uses proof of burn, POB. Factom is a blockchain solution that provides data integrity and auditability for enterprises. It uses POB to secure its network and ensure that only those willing to burn tokens can participate in adding new data entries to the Factom blockchain. Users burn Factom FCT tokens to participate in the validation process, thereby increasing the scarcity of the token and incentivizing long-term commitment to the platform. The main benefit is that Factom's use of POB helps reduce inflationary pressures by decreasing the token supply and encourages users to hold tokens for the long term. The benefits of proof of burn, POB. By burning tokens, the supply is reduced, potentially increasing the value of the remaining tokens over time. POB helps to secure the network by ensuring that participants are financially committed and willing to sacrifice their tokens for long-term benefits. The act of burning tokens shows a high level of commitment to the network, creating a stronger and more sustainable ecosystem. POB creates an incentive for users to invest long-term, increasing overall network stability and value. Conclusion: both proof of elapsed time, POET, and proof of burn, POB, offer unique solutions for blockchain systems. POET is energy efficient and ideal for enterprise-level applications, while POB creates a deflationary model that encourages long-term investment and commitment. Projects like Hyperledger Sawtooth, Slimcoin, and Counterparty are leading the charge with these innovative consensus mechanisms, making them highly valuable in the ever-evolving world of blockchain technology. Proof of impact, POI. Finally, let's take a look at proof of impact, POI, one of the most innovative proof of mechanisms out there. POI is designed to verify real-world social and environmental impacts, making it the perfect mechanism for projects that focus on sustainability and corporate social responsibility. Through POI, blockchain networks can track and reward verified actions that are making a positive impact in the real world, like reducing carbon footprints, planting trees, improving access to clean water, or promoting renewable energy projects. The idea is that individuals and businesses can earn rewards for their positive contributions to society and the environment. Proof of impact is revolutionizing the way we think about blockchain applications, moving beyond financial transactions to track tangible, real-world outcomes that benefit society. It's a powerful tool for encouraging social good and could reshape how blockchain is used, especially in sectors like environmental conservation, sustainable agriculture, and corporate social responsibility. How proof of impact, POI, works. In POI, verified actions that create social and environmental benefits are recorded on the blockchain. These could include activities like planting trees, reducing emissions, or supporting education initiatives. To ensure authenticity, PoI uses third-party verification systems, ensuring that the impact being claimed is legitimate and measurable. This could involve using IoT devices, smart contracts, or even volunteers to verify the outcomes. As individuals or organizations achieve measurable goals, they are rewarded with tokens or other forms of cryptocurrency, which can be traded or used within the ecosystem. Since the blockchain is a public ledger, all verified actions and rewards are transparent and publicly visible, ensuring accountability and trust in the system. Crypto projects using proof of impact, PoI. Power Ledger focuses on creating energy-efficient solutions by facilitating decentralized energy trading. It uses PoI to track the environmental impact of energy production and consumption, rewarding participants for making sustainable energy choices. Power Ledger uses the PoI mechanism to monitor the carbon footprint of energy producers and consumers. By tracking positive environmental impacts, such as the use of solar power, participants can earn tokens as incentives for reducing their carbon footprint. Power Ledger enables peer-to-peer energy trading while promoting sustainability and environmental responsibility. The PoI mechanism ensures that users who contribute positively to sustainable energy use are rewarded, creating a win-win situation for both the planet and individuals. Verra is a global leader in the carbon credit market and uses PoI to verify and track environmental projects that help in carbon offsetting. Verra's PoI framework verifies carbon-reducing projects to issue carbon credits known as Verified Carbon Units, VCUs. These VCUs are recorded on the blockchain to ensure transparency, traceability, and authenticity. Verra creates an auditable and transparent system that ensures carbon credit issuance and rewards those who participate in carbon offsetting, promoting environmental responsibility. ClimaDAO is focused on tackling climate change through blockchain technology. It uses PoI to track verified actions aimed at carbon reduction and offers a decentralized autonomous organization platform where users can participate in environmental initiatives. Participants in ClimaDAO can purchase carbon credits to offset their carbon emissions. These credits are tracked and verified using PoI to ensure they come from real-world actions like tree planting or renewable energy production. As users offset their emissions, they are rewarded with Klima tokens. ClimaDAO helps decentralize climate action by making it easy for anyone to contribute to carbon offsetting, while the PoI mechanism ensures that the carbon credits are genuine and backed by verified actions. From proof of stake to proof of view and beyond, these innovative consensus mechanisms are pushing the boundaries of blockchain technology in every direction. As PoS continues to grow in popularity for decentralized financial applications, mechanisms like POV, POA, and PoSpace are emerging as solutions to the diverse challenges faced by different industries. Proof of impact represents a bold new vision for how blockchain can be leveraged for social good, enabling real-world social and environmental benefits to be tracked, rewarded, and amplified. By integrating PoI into blockchain platforms, we're setting the stage for a future where positive impact is not just possible, but incentivized and rewarded. What's clear is that blockchain is evolving faster than ever, and with new and improved consensus mechanisms, we can expect faster transactions, greener networks, and a more inclusive, transparent world. Whether it's improving energy efficiency, enabling faster transactions, or creating authentic digital experiences, these innovative mechanisms will play a pivotal role in shaping the future of decentralized systems. The possibilities are endless, the future is bright, and the power of blockchain to make the world a better place has never been more real. Stay tuned as we continue to witness the evolution of blockchain in ways that will reshape industries and transform lives for the better. So, what do you think? Which of these proof of mechanisms are you most excited about? Let me know in the comments below. And if you want to stay updated with the latest in blockchain, make sure you hit subscribe and turn on the notification bell so you never miss an update.